section 6.6, inequality in two triangles. So we have this thing called the hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. This is an absolute mess in my opinion. So think of it this way. I got two pairs of scissors. They are not perfectly the same, but they're pretty darn close. So imagine. These are the same as these. We're going to make two triangles with the cutting parts of the scissors. So right now they're about congruent by side angle side. What if I make the red scissors? What if I open them up? Now these two lengths are still the same as these two lengths, but I made the angle bigger. When I made the angle bigger, the side became bigger. So the bigger angle makes the bigger side, the smaller angle makes the smaller side, and the triangle with the bigger opening has the bigger third side. This is what the hinge theorem says. If the two sides of one triangle are the same length as the two sides of the other, now these happen to be the same length because they're scissors. These don't have to be the same length, but these have to be the same and these have to be the same. As long as these are congruent and these are congruent, the bigger angled triangle has the longer third side. So let's actually draw this in picture form best we can. If you have two triangles, maybe that one and this one. This side is going to be bigger because it has a bigger angle, and this side is going to be smaller because it has a smaller angle. Now the converse is the same idea, just kind of the opposite order. The smaller angles make smaller sides. The smaller sides make smaller angles. The bigger sides make bigger angles. The bigger angles make bigger sides. It doesn't matter to me that you know the theorem versus the converse of the theorem. What matters to me is that you know the general idea. So let's look at example 1. Complete each statement with less than, greater than, or equal to, and explain your reasoning. So let's see here. We have in this picture, AB is congruent to DE, and AC is congruent to DE. So we have these two that are congruent, we have these two that are congruent, and we have a 35-degree angle and a 45-degree angle. The 35-degree angle makes the smaller side, and the 45-degree angle makes the larger side. So all we need to know is which way the inequality faces. So remember, it's kind of like a Pac-Man or an alligator mouth. It eats the bigger number. So if it goes this way, the bigger number is on the left. If it goes this way, the bigger number is on the right. Think of it as like a mouth trying to eat the bigger number because it's extra hungry. Different people, maybe you might have learned it Pac-Man, you might have learned it in alligator, you might have just learned it. Let's see here. BC is smaller, which means EF is bigger, so it should be facing to the right. BC is less than EF. Number 2, let's see here. AB and DE are congruent. AC and DE are congruent. 95 is bigger than 20, which means BC is the larger side and EF is the smaller side. So BC is bigger than EF. And the last one, let's see here. BA is congruent to ED. CA is congruent to FD. This angle is, if you see this little box in the corner, that's 90 degrees. This angle is 90 degrees. These two triangles are exactly the same. They are congruent by side, angle, side, which means BC is equal to EF because of the 90 and the 90. Let's continue with example 2. A bunch of the same problems, essentially. So complete each statement with less than, greater than, or equal to. So the measure of angle A and the measure of angle D. So look, 1 tick mark, 1 tick mark, 2 tick marks, 2 tick marks, 3, 3. These triangles by side, side, side are exactly congruent. That means the measure of angle A is equal to the measure of angle D. They are the exact same triangle. Number 5, the measure of angle A is blank the measure of angle D. So 1 tick mark, 1 tick mark, 2 tick marks, 2 tick marks. 14 is across from the A, 16 is across from the D. 14 is smaller, which means angle A is smaller and angle D is larger. The longer side makes the larger angle. So if angle A is smaller, then the inequality faces D. Number 6, the measure of angle A and the measure of angle D. 1 tick mark, 1 tick mark, 1 tick mark, 1 tick mark. 9 is across from the A, 2 is across from the D. 9 is bigger than 2, so A is larger, and D is smaller. So the measure of angle A is bigger than the measure of angle D. Number 7, AB and AC. BD is congruent to CD. Now, in order to use the hinge theorem or the converse, there have to be two pairs of sides that are congruent. So everything you've learned, this is like the last chapter of geometry first semester. Everything's fair game. And right here, the triangles share a side. So that side by reflexive property is congruent to itself. Now the 145 is across from the AB. 135 is across from the AC. 145 is bigger, so this side is larger. 135 is smaller, so AC is smaller. AB is bigger than AC. AB and CD. 1 tick mark, 1 tick mark, 2 tick marks, 2 tick marks. Hey, look, we have vertical angles. So this angle and this angle are congruent. So what does that mean about the sides opposite them? These two triangles by side, angle, side are exactly the same. They are congruent, so AB is equal to CD. Last one here, the measure of angle 1 and the measure of angle 2. We know AC is congruent to BD because that was marked. Ooh, look, we have reflexive again in the middle. Now angle 2 is across from the 17, and angle 1 is across from the 19. Well, 17 is smaller, so that means angle 2 is smaller. And the 19 is bigger, which means angle 1 is larger, because 19 is bigger than 17. So the measure of angle 1 is greater than the measure of angle 2. And with that, you should have enough information to go ahead and complete the homework for section 6.6.